calculation I will show you. First we will determine the voltage regulation of transformer. Now how to find out voltage regulation? For that formula, secondary voltage at no load minus secondary voltage at load divided by secondary voltage at no load. Okay, so we will calculate, if we have to calculate regulation at first reading. So first reading, no load voltage is 112 volt and load voltage is also 112 volt. So 112 minus 112, that becomes 0. So regulation will be 0% for the first reading. Okay, if at all we want to find regulation will be 0% for the first reading. So we will calculate it for second reading. How to calculate for second reading? Second reading, no load voltage is always 112 for all the calculations. No load voltage is 112 minus load voltage is for the second reading 109. So 112 minus 109 upon no load voltage is 112 into 100. So this gives you how much?
0.267.
So this gives me 2.6%. Okay, so this is how we can calculate voltage regulation for my second reading, which is 2.6%. Likewise for third reading, how you will calculate? 112 minus 107 upon 112, that gives you second regulation. Third, how you will calculate? 112 minus 106 upon 112. Next, 112 minus 104.5 upon 112. Likewise, you can calculate voltage regulation, and you will find that voltage regulation will gradually increasing. And if at all you plot the graph of I2, so that is secondary current I2 versus percentage voltage regulation, you will get the variation linear and you will get the graph straight line passing through origin. This is how you can get about the variation of secondary current or load current, that is you can also call it as a load current or secondary current, against the percentage voltage regulation graph. Now regarding efficiency calculations, so percentage efficiency you can calculate by ratio output power upon input power into 100, right? So how we will get output power in this case? Output power will get multiplication of V2 into I2 into actually cos phi, but cos phi is, we have used the lamp bank, which is a resistive load whose power factor is coming out to be 1. So you simply will get output power V2 into I2 because cos phi is 1 for resistive load. Upon input power is nothing but W1. Input power is nothing but the wattmeter reading W1 or P1, right, into 100. So let us calculate it for the, again if you see for the first reading you will get output 112 into 0, that means output power is 0 divided by input power 20, so that gives you 0. So your efficiency again starts with 0%. Like regulation, percentage efficiency also starts from 0%. Okay, so we will calculate the percentage efficiency for the second reading. So what will be the output power for the second reading? V2 into I2, so 109 into 0.6. So this is 109 into 0.6. This gives me output power. Okay, divided by W1 is input power is 80 into 2, that is 160 into 100. So how much this gives you? 109 into 0.6, 109 into 0.6 divided by 160. 0.4087 into 100. So this gives how much percent? 40.87%. So our efficiency is coming out to be 40.87% for my second reading, right? Similarly, third reading, how you calculate? V2 into I2, that is output, 107 into 2.2 divided by input power is 130 into 2. Similarly for next reading, 106 into 3.3, that is P out, divided by P in, 185 into 2. Likewise, you calculate all the efficiencies, and if you plot the graph, again if you plot the graph of load current or output current I2 against percentage efficiency, you will get the graph rising, and at a particular load condition the efficiency becomes maximum, and thereafter you increase the load, the efficiency will drop. So this is how you will get the variation of secondary current or load current I2 against percentage efficiency. This is the particular load at which you will get efficiency maximum. This is the efficiency you are getting corresponding to this loading condition. You will get efficiency maximum. And thereafter, if you further increase the load, because of increase in the losses, the efficiency further drops out. Okay, so this is the variation of load current or I2 against efficiency, and this is the variation of load current I2 against percentage voltage regulation. So likewise, I hope you can find out all the efficiencies and all the regulations for all these 10 readings. Okay, so thank you.